Hello, everyone. My name is Dhaval, a second-year graduate student at Dartmouth College. On behalf of the Innovators in Cognitive Neuroscience Organizing Committee, I welcome you to today's seminar. We are a collaboration between Dartmouth, the Penn, MIT, Gallaudet, Yale, Princeton, Harvard, and Columbia universities. The seminar is devoted to highlighting the innovative advances in cognitive neurosciences while leveraging science as a vehicle for social justice. Before we start, let us take a moment to reflect on the lands from which we are joining today's talk. I'm speaking to you from Hanover, New Hampshire, which constitutes the land taken from the indigenous folk, the Abenaki people. We believe that through the acknowledgement of the past times, we step towards more equitable and humane futures. We also urge that you use the link shared in the chat to reflect on the lands from which you are joining us. For today's talk, I'm excited to introduce to you Dr. Eshin Jolly. Eshin is a postdoctoral fellow with the Computational Social Affective Neuroscience Lab at Dartmouth College. His research broadly focuses on the psychological impressions that people form of others, their neural representations, and change in these representations with social interactions. Beyond academia, he has advisory affiliations with the startups More AI and Parsnip.ai, the latter of which he co-founded in 2020. Eshin received his PhD in cognitive neuroscience from Dartmouth College with Dr. Luke Chang as his advisor. Before that, he was a lab manager for Professor Jason Mitchell at Harvard University. Moreover, his BA in psychology, brain and cognitive sciences from the University of Rochester is accompanied with a minor in music and jazz performance, which leads me to speculate how today's talk might take shape. His talk is titled People as Context, a relational account of person representation and memory. Without further ado, please join me in welcoming Dr. Eshin Jolly.
Thanks so much for that. Really nice introduction, Dhaval. I'm really excited and humbled to be here. So thank you everyone for inviting me and the organizational folks behind the scenes. Before we get started, I just wanted to take a couple of minutes to highlight an organization that I've been working with for the past 3 years, and that is Code for America. Many of you who are based in the US might have heard of Teach for America, but Code for America is actually a separate, nonpartisan, non-political, charitable organization that was really started to address the widening gap between the private and public sector use of technology, particularly in this rapid era of change that we live in. And so they have multiple ongoing efforts doing things like improving infrastructure around the criminal justice system, improving access to food benefits and civil applications generally, and then moreover, sort of helping and empowering local governments and municipalities. Code for America is actually organized into a few local chapters called brigades that organize around the issues of the local areas. And I've had the pleasure of working with the Code for UV, or Code for Upper Valley, where I live, that covers Vermont and New Hampshire. And one of the projects that I've been the sort of technical lead for a couple of years now is what we're calling the Rural Internet Project. And so the issue that we've been trying to address in our brigade, but one that affects many people across the country, is the fact that despite all of the advances we've been having in the last few years in computing and artificial intelligence, so many people are being left behind simply because they have poor access to the internet. And so in the news, we often hear about the United States as this technological pioneer in the forefront. But I'd actually argue that behind all that fanfare is a country that really has some crumbling civic technical infrastructure, and there's a lot of people in need. And so to serve this particular purpose, we've been developing an app that we think hopefully will be useful to folks. And what it allows them to do is just measure their real world internet speed. And then it automatically aggregates that into a map of measurements that's publicly available. And it looks something like this. And so the hope here is that local municipalities can compare these to real world maps that are against the claims that internet service providers like Comcast make. And those claims are often entirely over-exaggerated. But without hard data, these communities that are underserved, and honestly, the FCC in general has no teeth to hold the ISPs accountable and to force them to spend their money, which they should be doing, on improving this infrastructure. So if any of these kinds of things sound interesting to you, I'd highly recommend checking out Code for America and giving back via civil service. What I should tell you is that you don't actually need to know how to code. You don't need to have technical backgrounds. So many of the skills that we as researchers sort of take for granted, like project management, knowing how to quickly find answers to questions, helping to interpret and frame issues, are all really, really useful to the efforts of Code for America. At the same time, you get to have a lot of fun and gain a lot of experience working together with people from different ages and backgrounds. And so if any of that sounds interesting to you, highly recommend checking them out. Alrighty, so with that mentioned, I'd like to turn to the main question that's the focus of the work I want to tell you about today, which is how do we represent and remember other people? In other words, how do our brains cognitively form a representation of another person? And is there any commonality with that representational format and how we later remember them? If you'll indulge me, what I'm hoping to do with this talk is to actually propose some initial support for a sort of theoretical account that diverges a bit from the sort of mainstream view in social cognition and neuroscience. I don't expect you to be fully convinced, but what I'm really hoping is that maybe this will spur some ideas and discussions for all of us. So we'll also look at for a couple of preprints on these ideas in the next couple of weeks and months. So I think a helpful starting place is really diving into the long history, a rich history in social psychology that has really emphasized how we think about people in terms of specific attributes or traits. The idea here is that person-specific features that capture the goodness or badness of our social or intellectual qualities form a kind of space that we can use to conceive of other people. The most famous model along these lines is arguably the stereotype content model, whereby these axes are referred to as competence and warmth. But there's a host of similar models in the literature that have just given different names to approximately the same axes. And the story goes that this space not only allows us to represent specific individuals, but entire groups of people. For example, those we might feel jealousy towards, envy for, sympathy for, or even care for. Now, there's been a lot of interesting work done looking at the neural representations of person perception in terms of these traits or personality attributes. For example, over the years, numerous researchers have performed similar studies whereby participants are shown behavioral snippets generated by researchers that are supposed to reflect underlying personality traits, let's say like extroversion or introversion. And when we ask people to reason about this information, we often see a set of brain regions, including the medial prefrontal cortex, temporoparietal junction, posterior cingulate, and anterior temporal lobes that we broadly refer to as the social brain. In fact, rather than just thinking about personality, many of these brain regions are just sensitive to the general congruency of trait or behavioral information, how it coheres together into a consistent unitary representation. Some really lovely work from folks like Mark Thornton and colleagues has actually aggregated over some of the most popular trait models in the literature by identifying what's common to them in a purely data-driven way. What they find is that a data-driven trait space does a remarkably good job at explaining neural population patterns in these same brain regions while people are doing these kinds of tasks. In other words, trait spaces seem to be experimentally reliable and useful for prediction. Mark, along with Diana Tamir and colleagues, have elegantly proposed a theoretical framework that describes how traits, along with mental state inferences, allow people to make accurate predictions about other people's actions and the transitions between them. But as rich as this body's work has been, I would argue that there's a little bit of a problem. And what that problem is that this isn't how we learn about people in the real world. In the real world, we have access to so much more information about people. And in typical lab studies, like the ones that I've performed, that many people in the field have performed, we're typically bringing people into a lab setting, introducing them to, let's say, a fictional character, giving them a list of behaviors that we, as researchers, has pre-selected on trait dimensions. And then we tend to find over and over again that in the absence of any other information provided to people, of course, they do in fact use traits to represent people. But in the real world, we know that people are embedded in social contexts, that they have relationships. And I think that this really begs the question, what really are traits? What are they capturing? And what are we studying? If we actually go back to the original work of folks like Gordon Allport and trait theorists and scholars at the time, we actually find many discussions around these very questions. In particular, traits were seen as a way to summarize, categorize, discretize complex types of recurrent social behavior into succinct abstractions. In other words, when someone makes a statement like Eshin is trustworthy, what they're doing is implying a history of positive, reliable social interactions, and potentially future interactions along those same lines, assuming, of course, that I'm a trustworthy person. In fact, it's these relational schemas that represent the regularities between interpersonal behaviors that give rise to trait perceptions in the first place. I really like this quote from an implicit personality theorist that captures why I think this point really, really matters. So this is David Schneider in 1973, who says, quote, "Much early research in the field may be a historical accident, stimulated by Ash's impression formation research, where traits had been merely used as a convenience. The fact of the matter is, we have little or no hard evidence on what the natural units of person cognition are. Given that a person can be described behaviorally, in trait language, or in the language of typology, how do we choose when to use a particular level? It could be argued that so long as researchers like us provide perceivers with categories of explanation, we can never hope to answer the question of which categories are naturally used by people." And so I think from this perspective, the claim I want to make is that this trait-centric way of looking at how we think about people is inadequate, and it's particularly inadequate at representing the rich interpersonal relationships of our social world. I think a relational view of how we think about people is very underrepresented in social cognitive neuroscience. And I think that underrepresentation raises the risk that we're building a science on the study of traits rather than the real interactions and relationships that are fundamentally summarized by them. So how else might we think relationally about other people and people representation generally? There's a couple of other areas in philosophies and science and psychology that I think provide a few different ways to think about this. So I'm just going to point your attention to a couple of them. Within social psychology itself, interpersonal theories, especially interpersonal emotion theories, have often conceived of the idea that what we experience in life, like our feelings, always occur in the context of our own relationships. Work on temporal interpersonal emotion systems by Emily Butler and colleagues have attempted to characterize this interplay between people as a kind of dynamical system. Depicted here are various example dynamics which occur in partner relationships, whereby the dynamics of feelings are always a consequence of both individuals' emotional states. Interpersonal theory's major assumption is that almost everything consequential in life is the result of a social interaction. In other words, if trait theory says how we think about ourselves drives our social interactions, interpersonal theory assumes that our experiences and our social interactions drive how we think about ourselves. In the world of clinical psychology, one particular school of thought was that of the interactional family systems view. Some folks here might be familiar with researchers like Greg Batson, who are most famous for their work on clinical diagnoses and schizophrenia. But practitioners in this group actually had their thinking more broadly grounded in relationships between people and the feedback systems that arise. By drawing on influences from cybernetics, the main thrust of this therapeutic approach was to highlight the fact that the solutions that people seek for therapy were only possible to achieve if their broader social context or interactional nexus afforded them the opportunity to change. There are also several notable system-centric social frameworks nicely outlined in this review by Mina Chikara and colleagues. It came out last year. I would highly recommend it to folks. In their piece, her and her colleagues outlined several theoretical accounts that stand a bit in contrast, again, to the mainstream views in social cognition and neuroscience. Some of the things they discuss are things like the social ecologic view, whereby psychological processes are fundamentally entangled with the social systems in which an individual is embedded. Social constructionism, whereby identities are always a product of the people and the sociocultural contexts in which they exist. Assemblage theory, which is the idea that we ought to focus our study to the shifting flows of relationships between people and their environments. And lastly, dynamical systems, the idea that behavior arises fundamentally through interactions, both between people and their environmental affordances. At the same time, there's been mounting evidence in fields from and studies done in cognitive neuroscience that seems to have identified a common neural system with common computations for navigation and relationally representing information in multiple domains, in a sort of domain general way, if you will. For example, The same neural systems that support spatial navigation, such as in virtual reality environments, such as depicted here on the left, the entorhinal cortex and the medial prefrontal cortex, also appear to support navigation in abstract domains, such as concept space, depicted here on the right. What's interesting is that these same systems also seem to support navigation in simple social spaces, such as when learning and later navigating a social network of hierarchies based on learned traits. What's really neat, though, is that these same brain regions also seem to support encoding real-world social relationships, such as the positions that we occupy in our social networks, without actually having to study or learn anything in an experimental way. In this study, people just view brief video clips of their classmates drawn from their real social network. And what's really interesting is that neural patterns in response to seeing their contemporaries spontaneously represent them in a relational way. That is, in terms of network metrics like social distance, eigenvector centrality, and brokerage. I think this body of work in Neuro seems to suggest that estimating and considering how pieces of information are related to each other, including people, may be a kind of core computation that's supported by a reliable set of brain regions. These include a combination of some of the social brain areas I talked about before, but also areas that are part of the medial temporal lobe system, like the hippocampus and retrosplenial cortex. Okay, so with all this background, what would a relational account of person representation and memory really imply? I think it would mean that perhaps the fundamental unit of person cognition is really the relationships between people, rather than the people themselves. In other words, the edges of a graph, rather than the nodes. And that perhaps people can act as contexts, and that their presence can constrain our memory and change the landscape of the actions that are afforded to us. Those are a lot of big words, but I'm sure many of us have had the kind of experience where we're reconnecting with friends from another phase in our life, picking up just where we left off. We're so easily able to resume old conversation, remember things we wouldn't normally think about, and even behave differently. I would argue that this continuity is possible because what our brains do is fundamentally represent people as a function of their connections and relationships, thus allowing us to move in and out of social contexts that transcend physical space and time. Now, this might seem a bit strange to you, but it's remarkably consistent actually with the notion of personhood in indigenous philosophy. In the lovely book, Braiding Sweetgrass, Robin Kimmerer describes how through an indigenous lens, a person is fundamentally a connected being who's defined by how they stand in relation to others. So in an attempt to combine what seems like a lot of disparate ideas, theories, and sort of suggestions here, what I really want to do is test a particular claim, which is, do the relationships between people really serve as the basis for how we represent and remember them? Now, to study this, we have to move beyond the decontextualized social experiments I was mentioning earlier, because we want to allow people the cognitive room to encode information in any way that they want. And what we really need to do along these lines is to experimentally approximate a social world. So how do we do this? Well, we can leverage something that people are already pretty familiar with, and that's television shows, in particular, character dramas. In the work I'll talk to you about today, we have people watch a rich character drama called Friday Night Lights. It came out a bunch of years ago. Some parts maybe don't hold up, but in our study, nobody had seen the show before. And really, the show follows a small Texas football town in a cast of about 11 central characters. Many of the things that people observe while they're watching the show are things like friendships, romances, family dynamics, and conflicts. And critically, we don't ask our participants to think about anything when they're watching, because we really want to understand how they're encoding this information naturally. So with this as our stimulus, I'm going to try to take this relational processing view and test some very specific claims. And those are, first, that perceptions and beliefs about social relationships ought to be a key dimension of individual variability, both in our cognition, but also in neural responses. And that neural patterns in these social brain areas ought to encode information about recurring social dynamics that people are observing. Next, that social memory ought to also be organized around social relationships, rather than person-specific features, or maybe even other features like time and place. And lastly, that people should be able to act as a kind of mnemonic context for social memories, allowing us to observe context-like effects in memory, similar to those we observe in temporal or semantic clustering. So this brings me to the broad outline of what I want to share with you today. The first part of the talk, I'll test these first two claims, discussing the neural variation and representation of relationships. In the second part, I'll describe and discuss how we remember other people and structure our social memories. And in the last part, I'll briefly discuss a bit of future work building upon these findings and ideas. Okay, so the first claim that I'm testing here is the idea that our perceptions and beliefs about relationships is a key dimension of individual variability. To test this idea, I used the character drama I mentioned earlier and collected a data set in which 35 people watched one episode of the show in the scanner. For this analysis that I'll show you here, we're focusing on 88 meta-analytically defined regions of interest. After people were scanned, we had them also complete two post-scan rating tasks. One where they rated each character on several trait dimensions, and another where they rated the beliefs that they had about the relationships between characters. Using these ratings, we employed a technique called intersubject representational similarity analysis. This is a technique that we can use to map between individual differences in one domain, like behavior depicted in the plane in the middle, with another individual differences in another domain, like brain responses depicted at the top. Visualized a little bit differently, we can take the pairwise similarity between participants' brain activity over time and try to model it as a function of their pairwise similarity in behavior or impressions. Then we can try to adjudicate between different models and test which best explains neural variability in a region. So the first model I tested was based upon participants' trait ratings of each character, such as how likable, annoying, attractive they were. We had participants rate every single character, each of these 11 main characters, that is, and then we built a model by essentially comparing the ratings across pairs of participants. And then what we do is we average across those similarities over all of the characters that people rated. We can then repeat this process for all pairs of participants, and this gives us a distance matrix that forms our first model of neural variability. In this model, each character is essentially a point in trait space, like trait-centric theories might suggest. And what we're doing is we're comparing distances between the same points across participants. Our second model was estimating using participants' ratings of the relationships between characters, such as how much the character on the left liked, trust, or listened to the character on the right. After rating all of the main relationships in the show, we again calculated the similarity between pairs of participants' social graphs on an edgewise basis. By repeating this across participant pairs, we again generated a distance matrix that forms our second model of neural variability, this time capturing individual differences in people's beliefs about the relationships between characters. So this gives us two models of neural variation, the left being one that captures the similarity with which people view characters based on their traits, and the right being the similarity with which people view characters based on their relationships. Lastly, oh, sorry, I should mention these are the real data. These are the actual distance matrices here. And so each cell is the distance between a pair of participants. And so the last step we can do here is to model variability in each brain region as a function of the distances and variability in our trait-based questions and the social relationships. Remember, our prediction here is that individual variability ought to be related to variability in our beliefs about relationships. So what do we do and what do we find when we get this, when we perform this analysis? Well, starting with trait impressions, we were actually surprised to find that variation in people's trait impressions don't explain variation in any brain region, even at liberal thresholds, even with the different variants of this trait model. What I think this suggests is that the similarity of our brain responses over time doesn't necessarily reflect the similarity with which we form person-specific impressions of others. When we instead look at our social relations model, we find that several brain regions are captured quite well. And many of those regions are those commonly implicated in social processing, like the dorsomedial prefrontal cortex, temporoparietal junction, posterior cingulate, PCC, and the superior temporal sulcus. Altogether, what this seems to suggest is that individuals with similar brain responses over time are more likely to form similar beliefs about relationships rather than similar trait impressions. So these results provide a little bit of support for our first claim that really individual variability in social cognition in a naturalistic context seems to have more to do with social relationships than it has to do with person-specific trait impression information. Now, what I've shown you so far is really about the variability across people. But what about inside an individual brain? In our second claim, what we want to test is the idea that if encoding relationship information is how we represent others, then we ought to be able to model neural patterns while people are watching the show as a function of the relationship dynamics that they saw. So to test this idea, we collected a second larger data set in which participants watched 4 episodes of the show. And this happened across 2 different scanning sessions. So this is about 3 hours of imaging data per person. What we did was we annotated each time point of the show for the visual or acoustic presence of each of the characters. That is, whether they could be seen or heard. Now that participants are watching longer, more dynamic interactions between these characters, we can try to model how these relationships change over time by asking, can we use character co-occurrences to model and extract relationships? If we can reliably extract recurring patterns of co-occurrence, then we ought to be able to approximately model key social relationships in the show, like mentorship, a love triangle, or a best friendship. To do so, I think it helps to consider that from the perspective of a single participant, what they're essentially watching is a social network evolve over time. Using our annotations, I identified stable co-occurrences that persisted and repeated over time, what we're calling social motifs. These are time points in the show with at least 2 people interacting and interactions persisting for at least 10 seconds or more. So using this way of modeling the show, we can turn to classic representational similarity analysis to model neural patterns. So as a single subject watches the show, they're seeing a bunch of different social interactions unfold over time. We can try to identify these recurring interactions using our annotations, depicted here in pink, blue, and yellow. And then what we can do is compute the distances between these motifs to generate a matrix that captures the variability in recurring social dynamics over all 4 episodes. Next, we can use representational similarity analysis to compute the similarity between multivariate brain responses at time points where these motifs occurred, and then and these patterns are capturing activity in local searchlights of the brain. And then we can compare these 2 distance matrices, effectively asking the question, where in the brain the local patterns seem to be sensitive to reoccurring interaction dynamics. So what do we do and what do we find? Interestingly, we actually find a pretty similar set of regions from our previous analysis. And so this includes, once again, parts of the medial prefrontal cortex, posterior cingulate, temporoparietal junction, anterior temporal lobes. But we also see parts of the retrosplenial cortex and hippocampus, regions that are both involved in these sort of relational encoding and map-like representations. Together, I think what these findings seem to suggest is that at the level of an individual participant's brain, regions involved both in social cognition, but also perhaps building and using relational representations seem to encode information about social dynamics within the show. This provides some evidence for our second claim here, that in the absence of a task, and in this naturalistic context, individual neural pattern responses seem to encode information about recurring social dynamics and relationships. So let me just summarize what I've shown you so far in this part of the talk. First, I provided some evidence that individuals with similar spontaneous neural responses in social brain regions form similar beliefs about social relationships, and that individual differences in trait impressions don't actually seem to be related to neural variation in any brain region. Next, I showed you that locally distributed multivariate patterns in social brain and even the broader mediotemporal lobe system seem to encode information about social interaction dynamics that people are observing. And then lastly, maybe in a naturalistic context, the relationships between people may serve a sort of stronger signal than the kinds of person-specific attributes that have been so emphasized by prior work. Okay, so I'm going to take a quick sip of water here and then move on to the second section of the talk. Okay, so in the second section, I want to dive a little bit more into how we remember other people. And I want to specifically test the claim that person memory is also organized around social relationships. So to do so, In the second data set that I described before, we actually had a third session that I didn't tell you about. And in this session, we had participants come back within a week of watching all these 4 episodes and perform a series of naturalistic memory tasks while they're being scanned. I'm only going to talk about 3 of them today, a free, cued, and character recall task, but feel free to ask me in the discussion portion about the other task or any more details here. Okay, so our main question with these tasks was really to probe social memory in multiple different ways and test what dimensions might structure social memory. We started with 4 categories that were motivated from the literature. Actions, based on some recent work from Thornton and colleagues. Traits, based on this mainstream view in social cognition. Locations, because of the link we know already from other fields between space and memory. And people, specifically other characters from our relational view. We did this by giving participants a cued recall task in which they were cued with a word from each of these 4 categories. And their job is to simply recall aloud the names of any of the main characters who come to mind in response to the cue. I'll play you some examples. The names of the cues for this participant are listed at the top here. And remember that these are all performed in the scanner. So you may want to adjust your audio a little bit. There's going to be a bit of ringing in the background. So here's the first cue, flirt.
Tyra, Tim, Smash.
Okay, that was flirt. Here's outgoing.
Smash. Tyra.
I'll spare you the other ones because they basically sound the same. They're just lists of character names that are being recalled by our participants. So Stadium would be an example of one of our location cues, and Lila, a main character from the show, would be an example of one of our person cues. Now, to test the claim that social relationships organize memory, we needed to develop a measure to analyze these recalls. Unlike traditional cued recall paradigms, there's no notion of correct answers here, right? So how do we go about testing this claim? Well, we borrowed an approach from the collective memory literature called mnemonic convergence. What this is simply the average similarity of participants' memories for each cued category. For folks with a neuroimaging background, this is simply the average intersubject similarity of participants' memories. The intuition here is that given that people watch the same narrative unfold, we can try to use the consistency across people captured by the similarity of their memories to test our claims. So let me walk you through how this works with a single example cue. So we prompt people with flirt, and they give us back a list of characters they remember. And we start by representing each person's recall as a binary vector, which indicates whether or not a character is recalled. So just ones or zeros. Then what we do is we compute the Jacquard similarity between these binary vectors for a pair of participants. This is just a metric that captures the ratio between characters that both people recalled and characters that either people recalled. And so values close to 1 mean that 2 people recalled the exact same set of characters, and zeros mean that there were no overlapping characters between a pair of participants' memories. Importantly, this metric allows us to avoid making the assumption that people need to recall characters in the same order. We're letting that vary deliberately because we're interested in the overall association strength between a cued category, actions in this case, and participants' memories. So we can repeat this over all pairs of participants and then average these similarities to ultimately get a convergence score per cue, like flirt, fight, and gossip. Then we can aggregate these scores within category to calculate an overall mnemonic convergence score for the entire category. Lastly, we repeat this across our different 4 cued categories, essentially computing the similarity scores for all of them. Finally, we can compare mnemonic convergence across our categories to test our claim that memories are more about social relationships than these other possible dimensions. So to orient you, on the y-axis is the mnemonic convergence. That's the average similarity between people's recalls. And the x-axis shows each of our categories. When we run this analysis, what we find is that person cues have the highest mnemonic convergence relative to other categories, above and beyond actions, traits, and locations. In other words, the memories that participants retrieve about characters are most consistent when we probe them with other characters. We've also computed this with alternate types of mnemonic convergence scoring, including things like leave one subject out accuracy. I'm happy in any of the sort of QA portion to discuss these alternate analyses, but they all paint the same picture here. So what these results seem to suggest is that people might both be entities to be remembered, but also the dimensions by which we organize those entities. In other words, in memory, people are more related to other people than they are to the actions they performed, the places they were in, or the traits that they exhibited. Now, this task was pretty stripped down, and the way we tested our hypothesis was by using experimental manipulations, using these categories, right? And people weren't really recalling rich memories about people. So you might be wondering, like I was, do relationships also organize the content of persons' memories? And if they do, can we, instead of manipulating experimentally, can we detect this in a data-driven way? So we had a second task where we had participants perform longer character recalls. They were given 2 minutes to recall whatever they could about a single person, as if they were telling somebody else about them. The task was broken up into sort of 3 phases, starting with a name and face of someone to talk about a minute to plan and think about what they wanted to say, and then 2 minutes to verbally recall aloud what they remembered about this character. For today, I'm just going to focus on this active recall phase where they're actually talking aloud. So let me play you a snippet of one of these memories. Remember, again, this is happening in the scanner. There's going to be that background pinging. But unlike before, the person is not talking about or responding to any set of cues. They're just recalling whatever they could about the coach of the football team.
Coach Taylor is someone kind of depicted as having the weight of the world on his shoulders. He has a lot of responsibility as a head football coach and also as someone who has a family. And so in terms of his family, he has a wife who is this like southern Houston, Texas woman who's blonde. And then he has a daughter named Julie.
Okay, so how do we go about modeling and analyzing these natural recalls? What we did was, first, after transcribing them, we actually annotated them for some of these hypothesized dimensions. For example, in the memory that you just heard, the participant mentioned, for example, in blue, some of the actions that the character took, that they screamed at team members or that they work really late hours. They also mentioned things like the locations this character was in green, like the locker room or being at the game. They mentioned some trait-like words, so things like being a workaholic or someone who cares a lot. And then they also mentioned other people and their relationships, like this character's wife, their daughter, and the other team members. So using a combination of automated part-of-speech tagging and manual annotation and filtering, we extracted all of the unique words across all of our participants' memories that fell into one of these 4 categories. What this allows us to do is to represent each memory as a vector of terms within each of the category, giving a matrix to us that looks like this. So the rows here are a single recall by a single participant for a single character, and the columns are all of the unique words in that category across all participants' memories, with indicators for whether that person remembered or didn't remember that word. We do this separately per category, and then using a technique called weight and semantic analysis, we can learn lower dimensional embeddings for each of these categories. All we're really doing here is learning a compression of the full vocabulary of actions, traits, locations, or people terms that participants used, and we're shrinking that down into a space that we can ultimately use to compare how similar people's memories were in terms of the content captured by each of these categories. So by projecting each participant's memories into this space, comparing their similarity, and aggregating, we can once again compute a mnemonic convergence score like before. This allows us to ask how consistent the content of participants' memories are in terms of these hypothesized dimensions, but in a purely data-driven way. Remember that people are just talking about characters with no other directions, unlike our cued recall task, so there's no real experimental manipulation here. Just like before, we perform an analysis comparing each hypothesized category, this time derived from these richer, longer, contentful character recalls. Again, like before, on the y-axis, you'll see a mnemonic convergence score. This is the embedding similarity of people's memories. So higher values here mean that memories are more similar, and lower values mean that memories have less overlapping content. And on the x-axis are these categories and the hypothesized dimensions we annotated for. So when we run this analysis, we find actually that memory content based on the relationships between characters has the highest convergence across participants. In other words, when you or I are recalling information about the same person, our memories are most similar in terms of how we remember that person's relationships, rather than how we remember the actions they took, the traits they exhibited, or the locations that they were in. So I hope that these two very different types of memory tasks and analyses convince you at least a little bit that social memory might be organized around relationships rather than other possible features or categories. Oops. So the,
okay,
there we go, sorry. So the last claim.
So you have the coach's wife and his
audio.
daughter.
Whoops, it's a little sneak peek, but the last claim that I want to test here is the idea that people can act as mnemonic context for other people. We know from a rich body of work on the study of free recalls that learned list items that are later freely recalled tend to cluster together in a way that reflects the temporal and semantic context in which they were learned. On the left here is a classic lagged recall effect curve, demonstrating that words that appear closer in time or position when they're studied also tend to be in closer time or position when they're recalled. On the right is a similar effect, demonstrating that words that tend to have similar semantic meaning also seem to be recalled closer together in memory. These kinds of findings have been interpreted as the evidence for the existence of contextual effects in memory. So using this approach, we wondered if any kind of clustering occurred in the free recall of other people. And specifically, if it did, whether it could be explained by the relationships between the people being recalled. So to test this idea, we had participants perform a free recall task that was really, really simple. Their only job was to recall or briefly describe, if they couldn't remember the names, any of the characters from the show in whatever order that came to them. I didn't highlight this earlier, but a key methodological point is that this is always the first task that we had people do. And this was deliberate because we didn't want the design of our cued recall task or our character recall tasks to affect the nature of their free recalls. You heard a quick example here. The audio transcription approach that we used is essentially the same as the cued recall task, but the person is just listing out names of characters that come to mind. I'll just try to play this again for you.
You have the quarterback who hurt his back, and you have Lila, his girlfriend, her mom, and her dad, and then you have the backup quarterback.
Okay, so unlike the classic memory paradigms I was mentioning a moment ago, there's no sort of canonical list that people learned. So there's no way to really model the recall position or order of a character based upon how they were studied. However, you might have noticed that this participant's recalls seem to cluster together in specific ways. And what we hypothesized was that the distances between characters ought to be driven by their social relationships. We tested this by building a series of competing models to predict why characters are recalled in that specific order. One way to think about this approach that a friend sort of helped me understand is it's like writing an email to a group of people and trying to understand why you're typing some people's names first in the to field before or after other people. The idea we're testing is the sort of ways that those names come to you ought to be grouped together based upon some sort of relationships that those people have, such as being friends with each other or having the same kind of social identity. So the first set of models that we tested was motivated again by this trait-centric view. Specifically, the first model we built captured the relative distance between characters in trait space. We again used these post-scan ratings participants made of each character. And what this allowed us to do was ask whether characters who are closer in trait space are also recalled closer together in recall. Our second model, based upon the most salient social identity in the show, rather than participants' own subjective impressions. And that was specifically whether a character was or wasn't affiliated with football. This allows us to ask if characters who are part of the same social group are also recalled closer together in memory. Our second class of models is motivated by the relational view that I've been sort of hammering about. And for that, we hand-generated social networks for each of the main characters based upon true family ties or friendship ties. Again, these are not subjective ratings. These are the true relationships that participants observed. And using each of these graphs, we computed the communicability between each pair of characters on the graph. What this allows us to do is to ask whether characters who are close as a function of their friendship or family ties are also recalled closer together in memory. So using each model, we can borrow a distance regression modeling strategy, where we first compute the distance between pairs of recalled characters. In this case, distance or dissimilarity simply means that characters are recalled farther apart in order. This produces a distance recall matrix per participant, and then we can try to predict the distance between any two characters in memory based upon their distances according to each of our models. Specifically, distances in trait space, their social group, the family graph communicability, and friendship graph communicability. Importantly, we jointly predict the recall distances to see which models best explains the structure of an individual person's memory and accounting for any variance explained by the other models. Okay, so what do we find? Well, before I show you the results, let me just orient you one more time. This plot's a little bit different than the ones before. On the x-axis are all of the models that I just described that we're testing. And on the y-axis is how well each of these models explain the distances in participants' recalls, accounting for how much explanation was provided by any other models. So higher values mean that a model did a consistently better job explaining the structure of memory across all the participants relative to other models. Values close to 0 indicate a consistently bad model fit to memory. And the dots you will see are the fits for individual people. We're doing this at the level of an individual subject's recalls. So when we look at our trait space or social identity models, we actually find that these do a pretty poor job at explaining recall structure. The average fit across people is pretty close to 0, with a lot of variability across people. But when we instead look at our relational models, we find that these significantly predict the structure of memory above and beyond other models. In other words, the distance between recalled characters can be predicted from their family or friendship ties. I should add that we built several controls into this analysis that I'm not depicting to try to account for other explanations, like the average statistical co-occurrence between characters or their overall on-screen time. And we were able to build these alternate models using the annotations that I mentioned from the social motif analysis. What I think is neat about this finding is that these are robust to these kinds of alternate control models. And so this seems to suggest that models built from relationship graphs are a pretty good fit to freely recalled social memories, accounting for alternative explanations, both that are social, temporal, and general saliency. So what I think these results seem to suggest is just like list items learned in adjacent positions, information acquired in a particular location, or the similarity in the semantic meaning of concepts, people can act as contexts that produce clustering effects in memory, driven by how socially connected they are. So let me just sum up this section. What I've showed you so far is in a cued recall paradigm, people, rather than actions, traits, or locations, seem to organize memory. That the content of people's memories also seem to be driven by how we remember their relationships rather than other features. That the social network distance between people seems to structure how we freely recall them. And more generally, that people might act as a kind of mnemonic context for other people, driven by the underlying relationships between them. So in the last couple of minutes here, I just wanted to showcase 2 ongoing collaborations, building upon and refining some of these ideas and explorations. The first is work with in collaboration with a graduate student, Wasida Mahapanet. And here, she and I are trying to build upon some of the motif analyses that I showed you. Specifically, we're trying to develop a learning model in conjunction with some richer annotations that we've been collecting to understand how people learn these social motifs and graphs in the first place. There's been some really interesting work in this area by Jay Sun, for example, but demonstrating that people can use social features to make cognitive map-like inferences over social networks, albeit in more traditional experimental constrained task settings. We're hoping to build upon this in a more naturalistic, task-free movie watching setting. The second line of work is in collaboration with graduate student Sushmita Saduka, where we're trying to build upon some of the memory findings that I showed you, and particularly connect them with neural responses. Currently, we're taking neural networks called transformers that power the large language AI systems you've seen in the news lately, and we're fine-tuning them on knowledge of the show using movie scripts from each episode. then we're trying to connect how these fine-tuned models represent the content of people's memories to neural variation in brain responses during recall. We're also hoping to model how these representations are related to variation during encoding, in other words, watching the television show. And hopefully this will allow us to understand how the encoding of social relationships is transformed during memory and recall. So let me just wrap up by summarizing the main things that I hope to sort of suggest to you today. And that's that one of the key ways our brains seem to spontaneously represent other people is as a function of their social relationships. And that a reliable dimension of how we remember other people is also a function of their social relationships. And that the same neural systems that appear to be involved in navigation, relational encoding, may actually play a broader role in naturalistic social cognition. And that like space and time, people might be able to act as mnemonic contexts. The relationships between people allow us to act as context for each other, structuring our memories like time and space. And finally, in the language of David Schneider, maybe relationships are the natural units of person cognition, specifically in terms of how our brains and mind process social information and think about other people. There's this quote from African philosophy that I think captures my overall claim pretty well. I'm not going to try to butcher it for you, but many of us might actually already be familiar with the term Ubuntu. It is, in fact, after all, the name of a major operating system that many of us who do technical work are used to using. But what you might not be familiar with is the full English translation. And that is, a person is a person through other persons. In other words, our very existence is in part forged through the crucible of community. We are who we are because of how we're related to others around us. And that may in fact be the very way that our minds represent and remember other people. So let me just wrap up by thanking all the folks that made this work possible. It's a ton of scanning hours, annotation hours, processing, and I couldn't possibly have done it myself. These include my faculty advisors, Luke Chang, Talia Wheatley, Jeremy Manning, my external faculty advisor, Janice Chen, and then all of the members of the COSAM lab, past and present. So Jin Chong, Wasida Mahatanit, Zainab Malani, Sushmita Saduka, Taylor Walsh, and Miriam Iqbal. So with that, I'm pretty much done, and thank you for your attention. I do want to leave you, if you'll let me, with one quote from an Indigenous scholar, Porter Swinstill, who I had the pleasure of hearing speak at the Santa Fe Institute this summer. It's from a book called Indigenous Knowledge Systems and Research Methodologies, in which he has a chapter discussing his perspective on reconciling life and identity as an Indigenous person existing within a largely westernized academic institution. I personally found it really inspiring as I try to live my science where I can. And so for me, really leaning into this relational view as a scientist means keeping in mind the responsibility that you always exist in relation to other people. You're always the product of everyone who came before you, and you're always an ingredient for all of those who come after. So thank you for indulging me, and I'm happy to take any questions.
Well, thank you for the great talk, Eshin. I'll remind everyone that if you have any questions, please to send them in through the Q&A box. We do have one question for you. It says, great talk. The questions are, first, with respect to the null training model findings, do you know if there was less variability in participants' trait ratings, which could drive the null result? Second, do you know if the trait model gets better over time, like over multiple episodes watched? The rationale here being that the spontaneous trait inferences may need more time for people to form schemas of characters.
Yeah, thanks for the great question. So maybe I'll answer them in the reverse order. We don't actually have multiple measurements of the trait questions, so I can't really answer that, but I do agree that by collecting how trait measurements change over time, we would be able to sort of adjudicate that a little bit better. I don't remember off the top of my head, but when we were doing some robustness checks, there isn't necessarily more or less variability between the trait, the way that people think about characters in terms of traits versus their social relationships. So I'm not sure that that would be the explanation for what we're seeing here.
Great. We are nearly out of time. So if someone would like to ask a question there, I think we can go for one more and then we can shift over to the Q&A Zoom room.
I have a question, Eshin. I'll take my panelist privileges. So I think it's a really interesting perspective, really like fresh take on like how we organize memories. I guess I'm trying to fit this into I'm trying to understand this in the relationship to events. So the fact that do you think about the events as being mostly that the people are recalling as being mostly about interpersonal relationships? Do you think that that's kind of these types of episodes are the granularity that the social network is being built, the relational network is being built? Like, what's the relationship between the temporal and the relational aspect of these things?
Yeah, so that's really a good question, because it's something I've often thought about. Like, there's been so much work recently on event segmentation, on the way that people sort of do this, prediction error, maybe one of these kinds of things. And so, I think maybe an underexplored area is that, like, in real life, we're very sensitive to when relationships change, right? And so, like, in a sense, that changes in relationship dynamics themselves could be a kind of event marker, right? There's a life before and after people that we use sort of colloquially in language, right? Or at a certain era when we had a certain kind of way of interacting with each other. But honestly, I don't know. And I think it would be a super cool area to explore, whether that's a way that we're like sort of parsing our experiences based upon how dynamics are changing maybe dramatically between the people we're interacting with.
Cool. So it is, that was a great answer. Thank you. And yeah, Deval, I'll let you wrap up because it's 3:30 and yeah, you can direct people where the next place to go would be.
Sure. Let me just post the link for the next Zoom room. Let's just join the Zoom room for other Q&A. This will be a more just life in sciences style Q&A. So Eshin will be here to talk about just general questions as well as the sciences. If you have any other questions, then feel free to join the other Zoom room. We'll shortly post the link over here in the chat as well. Thank you again for joining us. Thank you again, Eshin, for today's talk.
Thank you, everyone.